Hello, Minimis. Welcome. Minimis? Can you hear me?
Yes, Sorna. Yes, Sorna. Good afternoon.
Good afternoon,
Good
ma'am.
afternoon, Sorna. Okay.
Yeah, you have so many today, no? Sister told me she is very busy today.
Yes. Yes.
Ah.
2:30 we have another meeting, so I thought I will enter here and then join there. That's
Okay.
okay. Yeah.
Thank you, ma'am. Thank you for joining.
Yeah, yeah. We have our students and other students and faculty from other colleges.
Yeah, we have sent the link to so many people. So students and faculty from other college, they have joined. We have YouTube
Okay.
live also. There also because we
Oh,
have
okay.
more than 100 students. So all of them can
Okay then.
here.
Yeah.
Welcome, Sunny sir. Good afternoon, sir. Welcome.
Can you hear me now?
Yeah, we can hear you, sir. You're audible. Our Vice Principal Mini Joseph.
Good afternoon, sir.
Good afternoon. Good afternoon. Good afternoon.
Ankita has joined. Shall we start?
Yes, ma'am.
Yeah.
Shall I start now?
Yeah, we'll wait for 2 more minutes. It's
Yes, sure, ma'am.
58.
Yes, ma'am.
Okay.
Okay, ma'am.
Sunny sir, good afternoon.
Good afternoon, Andrew.
Yes, Ankita, it's 2 o'clock. I think we can start.
Okay, ma'am. Good afternoon, everyone. As you all know, that this current situation has imposed many hardships in one or the other way on all of us. But this has not dampened our zest to celebrate the annual Maths Fest. Today, I, Angita, welcome you all on the behalf of Mathematics Department of Vimala College to our virtual Maths Fest, Asthra, meaning an arrow to destination. It is in our culture to seek the blessings of God before starting a new journey. So now I invite Asha Mary for the prayer song.
സർവേശ്വരാനി കൃപാക്ഷത്തിനാൽ സന്തതം കൈകൂപ്പിടും ഞങ്ങൾ ശക്തി
Arsha, please unmute Arsha. Yeah, okay, continue.
സർവേശ്വരാനി കൃപാകടാക്ഷത്തിനാൽ സന്തതം കൈകൂപ്പിടും യും ശക്തി ചിത്തവിശുദ്ധിയും ഭക്തിയും ഞങ്ങൾക്കു നൽകണം നീ അറിവിന്റെ തെളിവേകി ഈ പ്രപഞ്ചത്തിന്റെ പൊരുളുകൾ അറിയാതെ കനിയണേ പിഴവുകൾ പറ്റാതെ എന്നെന്നും ഞങ്ങൾക്ക് തുണയായിടണം ജഗദീശ്വര ആയിടണം ജഗദീശ്വര.
Thank you, Arsha. Now, we are very fortunate to have an eminent personality who has achieved remarkable milestones in his field, Dr. Sunny Kuriakoso. So now I invite Miss Harriet to deliver the welcome speech. Over to you, Harriet.
Hello, am I audible?
Yes, Harriet.
Respected Chief Guest, Dr. Sunny Kuriakos, our college Vice Principal, Dr. Minimol Kijos, Head of the Mathematics Department, K. Swarna Ma'am, teachers, faculties, and students, and all my loving friends, a very warm good afternoon. First of all, let me introduce myself. I'm Harriet Edison, second year Max student. Today is a big day. Mathematics Department of Vimla College proudly presents Asthra 2K20, a virtual Max Fest. And today, we all are present here to be a part of this virtual fest. So, on this big day of celebration, the duty vested upon me is to welcome this gathering. First of all, I would like to welcome, and I take this opportunity to welcome our guest of honor, Dr. Sunny Kuriakos, Dean of Student Affairs, Visat Angamali. Sir, he's an eminent personality and he completed his doctoral studies at Cochin University of Science and Technology. He has published around 70 research papers. Sir, he's an active member of Kerala Mathematical Association and he has already delivered more than 200 invited lectures at various national and international seminars and conferences in India and abroad. And today we are very, very lucky to have sir, for inaugurating our Asthra 2K20. So, on behalf of the whole mathematics department of our Vimla College, I cordially and respectfully welcome you, sir.
Thank you.
Next, I would like to welcome our college vice principal, Minimol ma'am, to this event. Welcome, ma'am. Next, I would like to welcome our head of the department, Swarna ma'am, to this meet. Next, it's my pleasure to welcome all the other faculties and teachers of our college to this event. At last, but not the least, I welcome all the participants who have registered for the webinar session and the games and all my loving colleagues to this virtual gathering. Once again, by extending a very hearty welcome to you all, I conclude. Thank you.
Thank you, Harriet. Now I call upon Swarna ma'am, Head of Mathematics Department of Vimla College, to extend her felicitation to our guest of honor.
Thank you, Ankita. Good afternoon, everybody. Respected Sunny sir, Mini ma'am, my colleague, and my dear students. This is the month of mathematics. December is the month of mathematics because the great Indian mathematician Srinivasa Ramanujan's birthday falls on 22nd December and it is National Mathematics Day. We, the Department of Mathematics, Vimala College, have been organizing Math Fest in December for years. But this is the first time we are doing it in a virtual manner. The virtual map arrow, the arrow to the destination. My second year BSc students are master brains for this event and they have planned Polaris, a virtual mathematics exhibition and some games. All these events are conducted in the collegiate manner. I congratulate them for taking initiative and arranging this event. All the 5 batches of mathematics students are taking part in this event and I appreciate all their effort. Once again, we are proving that we are I wish them all success. Thank you.
Thank you, ma'am. Now comes one of the most awaited moments of this Maths Fest. That is the release of a virtual magazine, Polaris. So now I request our Vice Principal, Minimal ma'am, to deliver the inaugural address. A few words, ma'am.
Most respected Sunny Kuriakos sir, Head of the Department of Mathematics Department, Ms. K.L. Swarna, all the other faculty members of the Department of Mathematics, and my dear students. I am very happy to be a part of your program today, and you are organizing this on a virtual platform. Regardless of all the difficulties that we experience in face-to-face learning and teaching, you made it. You are continuing your good practices, the Mathematics Fest and other activities in the department. And I assume that this is a more of student organized seminars program with the support of your teachers. And I congratulate the department, faculty members and the students for organizing this program. And you make learning mathematics easier and enjoyable through this program, and you popularize mathematics to the community and especially for the students. So I am very happy to release Polaris, the virtual exhibition platform that is Asthra. And thank you everyone for this, and may this program bring out the best in you and spur you on to greater achievements. Thank you.
Thank you a lot, ma'am. One of our students have presented the magazine. So, our team, under the supervision of HOD Swarna ma'am and a mentor, Jinsi ma'am, have put in every effort we could to bring to you the feel of an exhibition while sitting at home. Our magazine, named Polaris, is based on the topic Application of Mathematics in Nature, Arts, Biology, and Sports. A brochure which will include the link of the magazine will be circulated, from which you can access the magazine. Talking about our fest, it is a 4-day long program starting from 16th of December, that is today, till 19th of December. Today, we will be having the official launch of our magazine, followed by a webinar. The schedule for next 3 days is as follows. On 17th, there will be a game, Strimco. On 18th, there will be another game, Kachibattam. And on 19th, finally, a last game, Ippo Sharia Kitaram. All these games will be conducted via Google Meet, and the timings are 2 to 3 p.m. The details of these games have already been circulated. Now, I know everyone is as much eager as I am to listen to Sir's webinar. So without any further delay, we can, Sunny Kuriakose sir, can we start with the
Yes, yes,
web?
yes, yes.
Thank you, sir. Over to you, sir.
Sunny sir,
Once again, good afternoon.
I request you to officially inaugurate our Math Fest, then followed by webinar.
Okay, okay. Good afternoon once again to all of you. At the very outset, let me express my sincere thanks and gratitude to the Department of Mathematics of Vimala College, Autonomous, Thrissur, for inviting me to take part in this 3 days long Asthra 2K20, a maths fest. Particularly, I am thanking Dr. Swarna for inviting me to do the honor of inaugurating this particular event, as well as giving me a chance to share some of my thoughts after being taught for the last 4 decades. Some of my own thoughts and some of the thoughts I have come across during these 4 decades among the budding young women mathematicians. I understand there is only one participant who is a male member, who is from FISAT itself, Mr. Andu. He is a very famous mathematics teacher of FISAT now. Thank you, Mr. Andu, for joining this particular event.
Thank you, sir. Thank you very much.
So, without much introduction, let me declare that Asthra 2K20, the virtual maths fest, is inaugurated with your permission. So that's the official inauguration of the maths fest. As it was mentioned by the speakers before me, we are all really stalled by the pandemic COVID-19, which is all over the world, not only a phenomenon in India, but all over the world. It is hitting adversely, and the entire activities are being affected. But anyway, we are hopeful that some remedy will be coming soon. So in that way, we can be hopeful and happy. Dear friends, for a mathematics student or for a good mathematics department or a mathematics group of students, this kind of constraints will never dampen your spirit or will deter you from doing wonderful things. This is the best example of that kind of excitement and indomitable determination and spirit that you took up this type of activities and doing it wonderfully. Remembering our own great Ramanujan, the Ramanujan's Day, the Maths Day falls on December 22nd in memory of our own legend Ramanujan. So, my dear friends, I wish you all the very best. Christmas is fast approaching. New Year is around the corner. So, I wish you all a very prosperous and happy New Year and very joyful Christmas. Now, with these words, I wind up my inaugural session, and I straight away go to the webinar. When your madam, Swarna madam, told me regarding the webinar, the topic, I was not very sure about the topic on which I have to speak. But anyway, being a program in the students level, and also so many students are not really committed to this type of seminars and webinars, especially after the lunch. I thought of speaking very simple and light things, not very serious things. And that is why I gave the title as Real Life Applications of Mathematics. Now, very often, mathematics is supposed to be a hard nut to crack. We know mathematics is not a very, very tough subject. It is the most interesting subject among all other subjects. We know that. But very often, the people, the public, they don't realize the beauty of learning mathematics. And I'm thankful that more than 100 students have joined, and they are listening to what I'm saying. I express my sincere thanks to Swarna Madam, the department as a whole, and the Vice Principal, Mini Madam, and all other officials who are responsible for inviting me. And also, I congratulate the department, in particular the students' team, the office bearers, and all for conducting this type of a mega event within all these constraints. In fact, opportunities seldom knock twice. This is actually an opportunity for us to explore various innovative things. This is an innovative method of teaching and learning, innovative method of communication. Earlier, in my old days, I have never dreamt about this type of things. But now I also have to be accustomed to talk in Google Meet, WebEx, etc., other platforms. So it is just become an order of the day, this type of programs. Friends, so mathematics, as I told you, mathematics is a very interesting subject. But very often, some of the students may find it very abstract. Mathematics is very abstract. It has no connection with the real life. No, you are wrong. I can talk hours on the applications of mathematics in real life. Mathematics and real life are very much connected and closely connected. In fact, any inquiry into the real line, we start with the real line, right? We start with the natural numbers, then comes rational numbers, then irrational numbers, then comes the real numbers, then complex numbers come only later. So we start from the real line, real numbers, and any inquiry into the intricacies of real line will definitely give rise to some theory, mathematical theory, no doubt about it. And we haven't yet explored at least a small portion of the real line. There are a lot of things yet to be explored about real line. And one thing that we know that is real line is not countable. That's all, right? Real line is not countable. And so many other things are there. So many properties. Some of the properties you have studied mathematically. Other physical and philosophical properties are also there. Ideas are there. But anyway, I'm not going to the details of that. So mathematics has tremendous applications in our real life. Now, I don't know what I should start, but I will start with some mathematical thing which has been recently developed, not very old, not very ancient mathematics, but relatively new mathematics. So I request all of you to see my presentation, then I will explain from there. Are you able to see my screen?
No, sir.
You are
No,
not able
sir.
to?
No,
It's
no.
not visible. It's not visible.
I'm not a computer savvy, that's a problem. So I have to share this one, then share.
Yeah, now
Coming,
it's
sir.
coming, sir.
Now it's coming, sir. Coming.
Coming, sir. It's coming. Okay.
I have to take the presentation. Where is that? Do you see the PPT?
Okay, sir. Okay.
Yeah,
Now it's
coming,
okay,
right?
sir.
Okay.
Yeah.
Sorry, I'm not a very good in computer doing all these things. Okay. So we only a few slides are. Don't worry about that. Don't be scared. I will show only very few. Being the Corona period, I thought of sharing a problem to diagnose a disease. Read this problem. This is a case came before a doctor. Let there be 4 patients having symptoms of illness, as one symptom is high temperature, the other is headache, the other is stomach pain, the other is cough, and the other is chest pain. And also the lab reports of all these symptoms are also known. We have some tests. The temperature may be using the thermometer, and headache is measured in some mechanism, stomach pain. All these are measured and the lab reports are available. What will be the correct diagnosis? Can you make a correct diagnosis out of this this data? This is a problem before a doctor. Okay. Now, being a mathematics student, in what way, how can we help the doctor in making the correct diagnosis? So let us see. Now we formulate this problem mathematically. That is what we do always, right? We will be formulating the problem as a mathematical model. So the problem goes like this. Let the set of patients be P1, P2, P3, P4. There are 4 patients, right? And the symptoms are expressed as a set S, as temperature, headache, stomach pain, cough, chest pain. Okay, these are the symptoms. Now, the lab report is expressed in terms of some relation. That relation may be unknown to some of you at least. It is an intuitionistic fuzzy relation from P to S. P means set of patients. S means the set of symptoms, right? Now let it be there. I will explain what is meant by the intuitionistic fuzzy relation. Is there anyone who knows fuzzy relation, fuzzy set, intuitionistic fuzzy, etc.? All right, I will explain it in one word. Okay, a fuzzy set, a fuzzy relation is a relation in which variables are related partially. Variables are related partially, or the relation is expressed in terms of a grade. In the classical case, the crisp relation is nothing but a relation which where the variables are either related or not related. Suppose we have the relation R from X to Y, then an ordered pair, every subset of X cross Y will be a relation. We have studied that. Every subset of a X cross Y is a relation. A relation from X to Y is a subset of X cross Y. And therefore, it consists of ordered pairs. Suppose X and Y, X comma Y is an ordered pair. That means if XY belongs to R, which means what? X is related to Y fully. But in this case, if it comes to fuzzy relation, X is related to Y with some grade. So if it is related, it is 1. If it is not related, it is 0. That is the usual thing. But the relation can be partial. It is not fully related. Little bit of relation is there. That type of linguistic relationship is modeled in terms of fuzzy relation. Do you get me? That is, 2 variables X and Y are related. Usually we write X, R, Y, means X is related to Y fully. That means ordered pair XY belongs to R. That means the grade of that relation is, that membership is 1. But there are situations in which the relationship is not exactly precise. It can be some partial relationship. So we allow such a relationship, and that is fuzzy relation. Okay, a fuzzy subset of the cross product X cross Y is a fuzzy relation. Now, what is intuitionistic fuzzy set? An intuitionistic fuzzy set is a model in which membership is given as well as non-membership is given. Now, today the results of the election declared, right? Therefore, the candidate who hasn't won may be interested in who all were against him. He can see by his vote how many favored him, but it is good to know how many did not favor him. That also is there. So we are interested in membership as well as non-membership. So this is the concept of inductionistic fuzzy. Inductionistic fuzzy set means it is a set in which every element has membership of belongingness and non-membership of non-belongingness. Okay, belongingness grade and non-belongingness grade, both are there. So now you look at the table. This is a table given from the lab. So the patient P1 has temperature 0.8, 0.1 means what? Suppose we have the symptom temperature, then the temperature, the patient P1 has not full temperature. It has 0.8 grade temperature. You can, or 80%, you can convert into percentage. Then it is the patient P1 has 80% temperature, and which is not favoring is 0.1 only. See that it is not 1 minus 0.8. It is not, usually it is 1, the non-membership is 1 minus. No, it is not like that. It has some other measure. Okay. Similarly, for the patient P1, how much headache is he has? He has 60% headache. He has stomach pain 2%, only slight stomach pain. He has only slight stomach pain. And what about cough? Oh, he is coughing. 0.6 is there. And chest pain, very little chest pain. Only the nominal chest pain he has got. That is the explanation of this P1. What about P2? P2 has no normal temperature. He has no high temperature. He has normal temperature. And headache, how much headache? He has 40% headache. And he has 60% stomach pain. And he is not at all coughing, only 0.1. And chest pain only 0.1. And what about P3? P3 has, temperature is 0.8 and headache is 0.8. Oh, he has temperature as well as headache. Maybe corona, I don't know. Stomach pain, not at all any stomach pain. And then cough, he is coughing occasionally, and he has no chest pain. So with this, and similarly for P4. So with this data, we have to, this is the data obtained from the lab. This is the lab report expressed in terms of inductionistic fuzzy relation. Okay, have you understood this much? This much is given. So the doctor has this much of information. With this information, he has to do some diagnosis. Okay, P1 has what disease he has. So he opens his medical books, and he has this type of data from the medical book. He has studied there in the medical college. In his MBBS or MS or MD, he has studied. These can be the possible diseases. This can be the possible diseases. What are the possible diseases? Diseases, viral fever, can be viral fever, malaria, typhoid, stomach problem, heart problem, or corona, whatever it is. At that time, there was no corona. So that is why there is no corona. Otherwise, I would have put it corona. So these are the possible, probable diseases with that symptoms. Okay. And in what way these symptoms attribute to these diseases? For example, if in what way they are connected? Temperature 0.4, it can be a viral fever. If temperature is 0.7, it can be malaria. If temperature is 0.3, it could be typhoid. If temperature is, what is the relation between temperature and stomach pain? No such relation, right? Temperature and heart problem, not much relation. So this is the fact or the information the doctor has from the books. He has studied this. He has this data from the database. Okay. And how headache and fever are connected? Headache and viral fever, headache and malaria, headache and typhoid, stomach, etc. These are this is the relation. This is the inductionistic fuzzy relation R. We call it as R from S to D. D is the disease set and S is the symptoms. These symptoms and the corresponding diseases are expressed in terms of this inductionistic fuzzy relation. Okay. Now what this he read from the so he has On one side, he has the lab reports, and on the other side, he has the textbook knowledge. Now, what he has to do? Now, he will compose. He will compose this Q and R. He will compose Q and R. And the composition, you just you do not worry about the calculations and all. We can calculate using this formula. It is a maximum of this one and all. Anyway, you just believe me for the time being. And this is the composition. This is what he gets using the composition. That is Q composition R. That is what he gets. Therefore, what is the conclusion? Now look at the final result. The final result is P1 has 0.4 viral fever only, malaria 0.7, 0.6 typhoid, 0.2 stomach pain, heart problem 0.2. So which disease may have this P1 patient P1? Highest grade is 0.7 for malaria. Therefore, the doctor diagnoses as the patient P1 has malaria. And look at P2. P2 has the highest membership on 0.7, 0.6, which is stomach pain. Therefore, P2 has no viral fever, no malaria, no typhoid, but stomach problem. He has some stomach problem. And what about P3? The patient P3 has highest grade for malaria, highest share for malaria. Therefore, he has malaria. And P5, the last patient, has the highest one as malaria. So he also has malaria. So this is how the doctor diagnoses this disease and give the final and prescribe the medicines for this. So mathematics is applied in real life situation, medical diagnosis. In fact, one of my research students, she did research in medical diagnosis. Not like this, not this one, but some other models we made. Dr. Vijay Lakshmi, now she's working in MES College, Kuchipura. Okay, so this is all about a medical diagnosis model. So we use the induced restrict fuzzy relation to model the, and we simply took the composition. Sometimes this composition we can fine tune this model and get better and better results. So much of research is being done in this direction. Okay. So this is one application that I wanted to share with you. Okay. Now I close this one. Just bear with me. I will do something else. Okay, I will. Just a minute. Please bear with me. ഹലോ ഇതിന് ക്ലാസ് എടുക്കാം പറഞ്ഞോ 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 ആയിക്കോട്ടെ ശരി ശരി All right. Can you see a whiteboard there? Do you see a whiteboard there?
No, sir, it's not visible.
Can you see this? What I am writing? You should be able to.
No, sir.
I will do it. I will do it again.
Yeah.
It's coming.
Yeah, presentation. Yeah.
So, you should be able to see. Just a minute.
Yeah,
can
now
you
it's okay. Yeah,
It's
we
okay,
can see.
right?
We can.
Yeah, yeah. Okay, okay. So next is this is one mathematical application. Next application that I can share with you is mm, something else. Okay, something else. Now suppose I need a number. I need a number whose square is the number plus 1. You got it? I want to find a number. I call this number as x. Okay, x is the number. I want the number, the square of this number as that number plus 1. What is that x? We can solve this, right? X squared minus x minus 1 equal to 0. What is x then? Come on, what is x? One plus or minus root of minus plus 4, right? By 2, which is same as 1 plus root 5 by 2 and 1 minus root 5 by 2. These are the roots. These are the numbers. So if you square this number, then it is nothing but this number plus 1. And this number, are you familiar with this number? What is this number called? This number this is not a rational number. This is an irrational number. This becomes 1.6 dash dash dash. Okay, or minus 0.61 dash dash dash. These are the two numbers. This is denoted by capital phi and this is denoted by small phi. And this phi is called the golden ratio. Have you heard about this golden ratio? There is, just now I heard that some of you mentioned about the nature. You are interested in studying the mathematics of nature, right? You look at this nature, you can see umpteen number of examples of golden ratio present there. For example, suppose you look at a flower, the petals are there. The petals are arranged not randomly, but the petals are arranged with some series, in some series. If you look at the coconut tree, the branches are there, the branches are arranged in some fashion. That is according to golden ratio. And what is this? This one is 1.61. You can simply approximate this. This is 10. That is 8/5, right? 8 by 5. Now, have you noticed the best, most aesthetic measurement is 5/8 or 8/5? If you see the credit cards, the ATM cards, all the debit cards, all these are in this shape. Length is 8 and 5 is, or the length is 2, the breadth it is 8:5. If you make something in this particular ratio, it will be more aesthetically beautiful. You can, if anybody has, just a minute. Hello? അതെ, ഞാനൊരു മീറ്റിങ്ങിലാണ് കേട്ടോ. So this is golden ratio. Now, suppose you are going to construct a house. How will you make a design? And this has a very close relationship with the Fibonacci series, right? Have you heard about the Fibonacci series? Leonardo Fibonacci, 1, 1, 2, 3, 5, 8, dash, dash. Adding the term consecutive that successive terms. This is a Fibonacci series. Now, suppose you take the ratio of this, the ratio of these consecutive terms, that will be a series, and that series will converge to this golden ratio. This has great applications. Now, the famous pictures, famous artwork, the paintings, Picasso, all those paintings were made with this golden ratio in his mind. So golden ratio was known before BC. Now, when will you say that a girl is beautiful? What is her most aesthetic height? When will you say that a girl is she has very good tall or good height? When will you say that? Or how will you measure the beauty of a person? Need not be a girl, a boy. How will you measure the beauty of a boy? Some people, some boys or some girls, their hands are more beautiful. Fingers are beautiful. How will you say that fingers are more beautiful? You can apply this and you can measure there are certain measures, the length between the different parts and the total fingers. And you can measure you can calculate some measures of the length of the face and the width of the face. And the distance between the eyebrows, your nose, all these measurements are there. If these measurements are in the golden ratio, that person will be more beautiful. I have used this golden ratio in the construction of my house. When I constructed my house, I applied this golden ratio wherever possible. I was teaching in UC College earlier. In UC College, there are two creative works. One is the gate itself. The college gate was designed using golden ratio. And also, there is a sculpture there, Mahaganidam. It is called Mahaganidam. So many people come and see it. They enjoy it. They say very good about it. So in Mahaganidam also, we incorporated golden ratio there in so many measurements. So if you can refer to this golden ratio to any site, there are so many materials available online. So you can refer to that. So golden ratio has the beauty of nature. I will say the beauty of the key of nature. Nature's beauty is nothing but golden ratio. Why the nature is so beautiful? Because everything is created by God in golden ratio. That's why it is called golden ratio. Sometimes it is called divine ratio. Golden ratio or divine ratio. Okay. So this is second application I wanted to share with you. Okay. Now I will share you with. Are you bored? If you want, I can share one or two more applications. Now we have. Now have you seen the tripod? You may be using that, right? Tripod. In fixing the camera and all, we are using 3 legs tripod. Why they are using 3 legs for fixing the camera and all? Why not 4 legs or more legs? Why they use 3 legs? Now very often you might have oh sorry, I'm very poor in drawing. Suppose there is a table. Suppose there is a table of equal legs. The length of each leg will be equal. Okay. Assume that this is a table. We name this as 1, 2, 3, 4. Okay, this is a table. And very often, the table is made perfectly all right. All the legs, 4 legs have same length. No problem with the legs. But while we go to a restaurant and while we sit on the table, chair and put our hands like this, it will wobble. The word for is wobble. It will നമ്മളെ മലയാളത്തിൽ പറഞ്ഞ പിടയ്ക്കാന്ന് പറയും. കൈ ഒരു സ്ഥലത്ത് കുത്തുമ്പോ മറ്റേ വശം പൊങ്ങും. അങ്ങനെ ഇതൊന്ന് പിടയ്ക്കും കിടന്ന് മേശ കിടന്ന് പിടയ്ക്കണതാണ്. പലപ്പോഴും വല്ലാത്ത സിറ്റുവേഷനൊക്കെ ആണെങ്കിൽ ഇത് പിടച്ച് ഗ്ലാസ് ഒക്കെ താഴെ പോകും. ശരിയല്ലേ? നമ്മൾ ഹോട്ടലിൽ ചെല്ലുമ്പോഴൊക്കെ ഇങ്ങനെ എന്താ കാര്യം എന്ന് വെച്ചാല് ദാറ്റ് ഈസ് ബിക്കോസ് ദി ഫ്ലോർ ഈസ് നോട്ട് ഈവൻ. ദ ഫ്ലോർ ഈസ് നോട്ട് ഈവൻ. അപ്പൊ അങ്ങനെ വരുമ്പോ അത് വല്ലാത്ത പ്രോബ്ലം ഉണ്ടാക്കാറുണ്ട്. നമ്മൾ എന്ത് ചെയ്യും? ബട്ട് ഇഫ് യു നോ മാത്തമാറ്റിക്സ്, you can solve this problem applying some mathematics, right? What you have to do is you just rotate this table by 90 degrees. So if you rotate this, for example, suppose if there are 3 legs, we can fix that 3 legs, no problem, right? So this one is above the ground, above the floor. That's why it is not fixing. So this leg is above the floor. It is not touching the floor. It is above the floor. All the other 3, that is second, third, and fourth, are now fully on the floor. The first one is just little bit above the floor. Okay. What you have to do is to solve this problem. Being a mathematics student, what you can do is you simply rotate the table. You rotate the table anti-clockwise by 90 degrees. In that case, the leg 1 will come to leg 2, 2 will come to 3, 3 will come to 4, and 4 will come to 1. Okay. If you rotate 90 degrees, 1 quarter, we rotate 1 quarter. Okay. So that will be the new position. And during this rotation, there will be at least 1 point where all these 4 legs will be fixing on the ground. You can experiment it. You can experiment it at home. At least there will be at least 1 point in this quarter rotation where all the 4 legs are fixed. There won't be any wobbling. അനങ്ങാതെ അത് കറക്റ്റ് ആയിട്ട് ഫിക്സ് ചെയ്യും. സംശയം ഉണ്ടെങ്കിൽ നിങ്ങൾക്ക് പോയി നോക്കാം. ഇത് വെറുതെ പറയുന്നതല്ല. There is a mathematical proof for this. Okay, now let us prove this. We can explain this. Okay, so let us assume that at a time t is equal to 0, the leg 1 is little above, or suppose h denotes the height between the tip of the leg and the floor. This is positive. Okay, and or put it as x for easy, for more convenience you can put x. X is the height of the leg from the floor. Okay, now you turn this at t is equal to 1. At some point t is equal to 1, this t becomes less than 0, because it is the floor is not level. Therefore it has to cross that means it is to be cut off, or that leg is to be cut off to fix there. Therefore mathematically, suppose we have this one, this is along the time, this is along the x means the distance, the height. Okay, so at time 0 it is positive somewhere here, and at time 1 it is minus, and the movement is continuous. Okay, the movement is continuous, and it is a function of t. Okay, it's a function of t. Therefore, if we draw the graph, f of t is positive at one point and negative at some other point. Therefore, by dash theorem, what is the theorem called? By dash theorem, there will be at least one point which crosses the x-axis. That means the distance is 0. It is the great mean value theorem. So if you study the mean value theorem, this is the best application. You can go to a hotel, and you can see whether there is any table wobbling there. And if there is a table wobbling there, you just call the waiter there and you just rotate it. Definitely it will fix at some point, provided all the legs have same length. If one leg is not equal to the other legs, length of the other legs, we can't help. But normally, when the carpenters make a table, all the legs will be of equal length. The problem is with the floor. So the problem with the floor can be solved, can be overcome by simply rotating the table a quarter 90 degrees. Therefore, at least one point it will definitely fix. So this is another application. I think I have to stop now, right? Or I can give you some other application if you want. I'm not getting any response from you. Do you follow, or have you slept already? I don't know. I don't know.
So the class is very interesting, sir. We
So
would
if
like
you
to
have
hear
any,
more.
yeah, if you have any problem, you can tell me. Now I will give some proposition to you, right? I will give some homework. Now, have you heard about? No, not heard. So now you know that what is a line? I told you the entire basis is the real line, right? Real line. I will tell you like this. I was a point in the womb of my mother. I was a point. What is a point? Can you define a point? Can anyone define a point? I'm sorry, nobody has ever defined. That's a fact. Nobody has ever defined a point, including the godfather of geometry, Euclid. He tried his level best to define a point, but failed miserably. He could not define it successfully. So a point remains still now undefined. Okay. So I was a point in the womb of my mother. I came out, and I started growing. I became a line. That's my real line. Okay. That's my real line. This is real line. Another line also, my wife came to my life. This is my wife. And we have, what is made? So many children were born. So these are all children, our children. This is father, this is mother. These are all children. What is a new world now? What is a new world called? Plane, right? It is plane. So earlier it was only line. Now it is another line also came. Then we became a plane. Okay, plane. So you study everything in this way only. That is, the starting point is real line. So if you study linear algebra vector space, what is the first thing you study? You study the first vector space as a standard real line. While you study topology, you study about topology on real line. So what all higher mathematics you study, it is all based on the real line. If the starting point is real line, then you come to R2. So when R is another R is coming, then we have R2 or the plane. Okay, R2. Now suppose we have a closed figure in R2. How many polygons? You know what is a polygon? What is a regular polygon? A regular polygon means sides equal, sides and angles equal. So this is a regular polygon. Square is another regular polygon. Then pentagon, hexagon, octagon, n-sided polygon. How many such polygons are possible in a plane? How many polygons can be drawn on a plane? Regular polygon, I mean. Tell me, how many regular polygons can be drawn on a plane? 4. Tell me. I need your infinite. That's right. There are infinitely many regular polygons drawn that could be drawn on a plane. Okay. Now this is the case of R2. In R, then we have R2. In R2 we have infinitely many regular polygons. While you come to R3, square in R2 has counterpart dash in R3. What? Suppose we have a square. Okay. Yeah, it will become a cube. That's right. Cube. Similarly, we have other solids. How many such solids, regular solids, are possible in space? Come on. How many such? Infinite, right? You will be tempted to say infinite, but there are only 5 regular solids. There are only 5. We can prove it, or it is in graph theory books. You can refer to some books in graph theory. They are called Platonic solids. Platonic solids. There are only 5 regular polyhedra. One is tetrahedron, then hexahedron, octahedron, dodecahedron, icosahedron. So there are only 5 regular solids in R3. Now, why I said all these things? What about R4? What will be R4? What will be the situation in R4? What all things which are holding true in R need not be true in R2? Another property I can explain. Suppose I delete one point from R2, then this R becomes disconnected, right? Connectedness you have studied. Am I right? So if I delete one point, then the whole R becomes disconnected. Whereas if I delete one point from R2, does it become disconnected? No. So deletion of one point makes R disconnected, whereas deletion of one point does not make R2 disconnected. So that is a property. Similarly, we have infinitely many regular polygons in R2, and the counterparts, the polyhedra, regular polyhedra, there are only 5 regular polyhedra in R3. And what about R4? What about R5? Is there higher dimensions? You have to think likewise only. Okay, you have to think yourself and see. Instead of simply mugging up things, what Swarna madam teaches you, you just question her always. Why it is no? Why it is like that? Why it is not like that? That type of questioning attitude you have to inculcate, and you are doing lot of extra work besides your textbook learning. And this is Swarna madam, and this is a student. And only when the student thinks a different perspective, then only the plane is made, right? Whereas if all students are thinking along the direction of the thinking of your madam, then no plane is created. Only the line will be there, right? Only non-collinear lines determine a plane. So you have to have a different line of thoughts. Maybe it may not be perpendicular, but oblique axis is there. So what is required is you always practice questioning all the things you study. The textbook, what is given in the textbook. While you read a textbook, you always question that. While a teacher is teaching, you always question that in your mind, at least in your mind. Why it is not so? Why it is so? So you have to question that. How many apples might have fallen on different heads? But all people thought, how many similar thoughts, they have same thoughts, and when apple falls on fell on one head, Newton, right, he thought he had a different line of thought. then a new creation is made. The theory of gravitation was born only by thinking differently. So my just suggestion is think differently. Then definitely you can be a standing out mathematics student and eventually a great mathematician. And with this, one more simple thing that I will explain and then I will wind up. Okay. This is a simple thing. This is my own findings. You can't find it from any textbook. Okay. Suppose we have two sets A and B. We have the set operations. We have the set operations A union B. We have A intersection B. We have A complement. Okay. All right. So these are the standard operations in the power set of X, non-empty set. All right. Now, do you have any significance, relevance for this, even this notation? I can tell you, not only the theory, the theorems and all have applications, but even the simple notation has some application, okay, in our life. Now, if you have, if A is me and B is my classmates, your friends in the group, okay, your classmates, and suppose you take the union of A and B, then A union B is bigger than A. A union B is bigger than B. A union B contains A and B. Or if you take union, you will get more and more might. You will be mightier, right? So always take union. That is why the proverb unity is strength. Always take unity, union, then you will have more strength. More strength. What about intersection? What about intersection? Intersection means something is very common to both A and B, right? This is the intersection, means something common to both A and B. And whenever there is common, something common to two persons, there is always a chance of quarrel, right? Very often, Kashmir is becoming the commonplace of India and Pakistan, and that is a root cause for all quarrel and all wars and fighting and all. So, common means fighting. Intersection means fighting. So, intersection, union means unity. Intersection means fighting or quarrel. All right. So, this notation tells you if A and B, you and my friends are intersecting, what will happen? Now, I will show you where is God. God is somewhere here, right? This is God. And God is showering blessings from above. God is showering blessings from above abundantly. And only if you and me are in union, we are in good fellowship, we are loving each other. If you love your neighbors, your friends, your classmates, then you can receive abundant blessings. Whereas if you are quarreling each other, no drop of blessing will go inside. Every drop of blessing will be wasted. So what we have to do? We have to be always in union to receive the abundant blessings from God. To become mightier and mightier, you have to be in union. Whereas if you quarrel each other, you will both become worse and worse. Your might already existing might will be lessened. So my last and final suggestion is be always in union. You are working as an association, right? Your Asthra is an association activity. So if you work in an association or in a group, always think of your fellow beings and be always in union. Be always inclusive rather than exclusive. Therefore, this is the notation, this is the message, great message. If all people around are all in union, we can definitely, that society, that community will definitely receive abundant blessings from above. So this is the the simple but very, very elegant message that the union intersection symbols can tell you. Similarly, the real line, any theorems, Laplace theorem, whatever theorems, Weierstrass theorem, Bolzano theorem, every theory you study in mathematics has some applications in real life. Our aim is to find out the applications more and more. You know, once upon a time there was strong number theory. They never thought that it has application potential in cryptography. Yes, now it is applied in cryptography and coding. So it is a recent latest theory. We are applying the number theory which once developed now. Therefore, every branch of mathematics, every theorem or every proposition, even a simple mathematical statement has tremendous applications in real life, but we seldom see it. We should be prepared to, we should be open to see the applications. With these words, I conclude. If you have any queries, you can ask. Otherwise, I will wind up and wish you all the very best in your coming days, in your career, in your life, and Christmas greetings and Happy New Year to all of you. If you have any doubt, you can ask me now.
Thank you very much, sir.
Thank you.
Students, if you have any queries, either post it in the chat box or unmute and ask.
आपको तो മനസ്സിലായി കാണില്ല അത് കാരണം നീ
Come on.
Okay, thank you so much. Thank you so much.
Thank you.
Shall I quit? Any doubt or any comment? You can disagree with me, no problem. Thank you. Thank you.
Yes.
Hello.
Okay, so if nobody is having any queries, Ankita can continue. Yeah. What else you have? Is Asha?
Ma'am?
Yeah, Amy? Yeah.
No. Can I continue with my vote of thanks?
Yeah.
No one is having any doubts.
Yeah, there are no doubts in the chat box. So you can.
Okay, ma'am.
Mm.
Good afternoon, one and all present here. Myself, Amy Rose from S4 BSc Mathematics, and I'm here to deliver the vote of thanks. First of all, I would like to thank Almighty God for blessing us to conduct such a wonderful program. Next, I would like to thank our resource person, Dr. Sanjay Kuriakose sir, for enlightening us with his knowledge on the topic real-life application in mathematics. This webinar gave deep insight into the topic, and I'm pretty sure this will surely help us in our further studies. Once again, I would like to thank Sir for taking time for us from his busy schedule and enlightening us with his knowledge. Thank you, sir. Now, I would like to thank our dear principal, Dr. Sister Beena Jose, and Vice Principal Minimus for supporting us for this program. Next, I would like to thank our department HOD, Swarna Miss, for her valuable advices and contributions throughout this section. Now, I would like to thank our class tutor, Jinsi Miss, for helping and supporting us to organize such a wonderful program. I also thank all the respected teachers of the mathematics department for their support and encouragement. Last but not the least, I would like to thank all the participants for being attentive and making this webinar a grand success. Once again, thank you all for your valuable presence. Thank you.
Okay, thank you, everybody. I think the program is over. So from the bottom of my heart, I thank Sunny sir, Mini ma'am, and all the participants. We have participants from all over India. So I thank all the participants for making this webinar a success. Thank you. Thank you very much.